Hello everyone, this is Daily Developing here, and today we're back with an interview question that was asked by Google. So without further ado, let's jump right in. So in this problem, what we have to do is we are given this map right here, all right? So the X is where we are, and O's are like where the coins are. So we're given our coordinate and the coordinate of all other coins. And so what we have to do is we have to find the closest coin. So in this case, this is what we're given programmatically, right? So our position is 0, 2. So 0, 0, 0, 1, 0, 2, right? This is our position. And then these are all the positions where the coins are. And so, we need to write a function that would find which coin is the closest to the origin. Not to the origin, but to our position. So as always, I will encourage you to stop the video, try to solve it yourself. And once you try it yourself, then get back to me. Okay, so this is the last warning. If you haven't paused the video yet, do so, because I'm going to now show you the solution. So first thing that we have to go over is the distance formula, right? So the distance formula is square root of, in parentheses, x minus x1 squared plus y minus y1 squared, right? This will give us the distance between 2 points. And so the idea here would be we have to take, so here's our position, right? And here are all the other coins. We need to find the distance. We need to find all the distances and then find which of the distance is the minimum. Okay. So let's do it. Let's first write the position equals 0 and 2. Well, now the coins are at right here. Okay, let's position and coins. Okay. Now let's get rid of this pass. So let's just say that the minimum, here we're gonna save the index, right? So we have in this array of all the coins, right? And now we have to loop through them and find whichever's closest, right? So we're gonna save this in min. Let's start by saying first coin is the closest. And then start comparing to other coins. So the way we're gonna do it now is, let's create for I in range from 1 to length of coins. So we start from 1 because here's the minimum, right? So by default, we just pick that. We say that 0th coin is the closest. And then we just have to check, all right, is first coin, are any of them smaller than the 0 one? So here we have to write two functions. So which one is the previous distance? Previous min distance equals to, so what we have to do is math. We have to import math, right? So what we have to do here is math square root. Okay, and now what would that be? Would be position. So where we are right now, that would be 0, right? That would be the x minus, so coins, minimum coin, again get the x, and then square plus position 1, so now y minus coins minimum 1, right? So y1, and again square that. Okay, so this is the distance of the previous line, right, that we have. And now let's do the current distance, because again we have to compare our current distance to our previous distance, right, to find the smallest one. So pretty much what we're doing here is we take, so far which line was the shortest, and in this case we're saying this in min. Okay, so far this min was the shortest, and then we are comparing this to current. And what we're going to do with current is the same thing, except for it's going to be with I. So Our current one is I. Okay, so now we found the current distance. Now we just compare. So if current distance is less than previous min distance, then min equals to I. Then we found a new minimum, I, and now we have to again loop through them and find whichever is even smaller. So now we have to return min. So now, as you see, it's 0, 4. So we looped through all of the coins and we found the smallest one. So I hope everybody enjoyed this video. If you did, please put thumbs up. It will help us in the YouTube algorithm. And see you next time.